Hi students, Professor Nugent here. Let's look at the instrumental variable setup extended to the multiple regression model. We're going to call this structural equation as the equation for our dependent variable y1, that's our dependent variable of interest, equal to beta naught plus beta 1 y2 plus beta 3 z1 plus u1. So again, y1 is our dependent variable of interest. We have y2 here on the right hand side as an explanatory variable, and we use y for this explanatory variable to indicate that this explanatory variable is endogenous. That is, this explanatory variable, y2, is correlated with the error u1. We have another explanatory variable, z1, that is exogenous. So z1 is uncorrelated with u1, and u1 is our error term. We also have, because y2 is an explanatory variable in our structural equation and it is an endogenous variable, in order to get an unbiased estimate of beta 1, we need a instrument z2 for y2 that satisfies the following assumptions. One, z2 should be uncorrelated with the errors. So the covariance between z2 and u1 should be 0. 2, z2 is excluded from the structural equation. Assumptions 1 and 2 go hand in hand. Assumption 2 basically means that if you included z2 in the equation for y1, that the partial effect of z2 on y1 would be 0. Okay, so z2 does not form part of the population true structural equation up here. And 3, z2 is relevant for y2. So recall that we called this our exogenous assumption. This is our exclusion assumption. This is our relevance assumption. We need all three of these things to be met for z2 to be a good instrument. Given these assumptions, and that z1 is uncorrelated with the errors as assumed exogenous, we have a set of moment conditions. These moment conditions are expected value of z1 u1, this is equal to the expected value of z2 u1, which is also equal to the expected value of u1, and these are all equal to 0. These moment conditions can be used to obtain the estimators using a random sample. let's do that. So we will have 3 equations based on the 3 moment conditions. Well, we have the sum from I equals 1 to n, y1i minus beta naught hat minus beta 1 hat y2i minus beta 2 hat z1i, and that equals 0. In the second equation, we have the sum from I equals 1 to n of z1i, and the same thing in parentheses. In the third moment condition, we have the sum from I equals 1 to n of z2i, and the same thing in parentheses. Equals 0, equals 0. So this last moment condition here is solved by the sample analog in the first line. The moment condition here is solved by the second analog in the second line. This one here. And this moment condition is solved by the sample analog in the third line. We have 3 equations and 3 unknowns. The unknowns are beta naught hat, beta 1 hat, and beta 2 hat. So with 3 equations and 3 unknowns, we can solve these equations for the estimates. In the multiple regression case, a reduced form equation will inform a perspective of the relevance assumption in terms of partial correlation. So we can write y2 equals pi naught plus pi 1 z1 plus pi 2 z2 plus u2, where the expected value of u2 is equal to 0, and the covariance between zi and u2 is equal to 0 for I equals 1, 2. The identifying relevance assumption is given by pi 2 not equal to 0. Alright, so we're saying that our instrument Z2 matters for our endogenous explanatory variable Y2 using this reduced form equation given by this big star here, with the statement that pi 2 is not equal to 0. And we can test for this using a t-test under the conditions that these assumptions are met. We will also have a reduced form equation for y. The reduced form equation for y is y1 equals gamma naught plus gamma 1 z1 plus gamma 2 z2 plus e1, where gamma 1 is equal to beta 2 plus beta 1 pi 1, and gamma 2 is equal to beta 1 pi 2. Finally, E1 is equal to U1 plus beta 1 U2. It is less common to work with the reduced form equation for y. The reduced form equation for y2, It is less common to work with the reduced form equation for y1. It is very common to work with the reduced form equation for y2. This equation up here. In later videos, we will refer to this reduced form equation as the first stage. Stay tuned to the next video and we will discuss two-stage least squares, where you will see how this first stage equation plays a role in estimation.